We will all agree on the fact that many processes in our body are beyond our consciousness. We don't heal our wounds deliberately and never have to think about digesting the food we just ate. This evidence might lead us to consider that science isn't yet aware of everything going on in our organism. Since Aristotle, most human beings experience the world through 5 senses: taste, smell, hearing, sight, and touch. But we can also all agree to say that we're not limited to these few. In other words, without proprioception, equilibrioception, thermoception, and nociception, our environment would seem quite odd and hostile. Therefore, we were gifted with senses informing us on what's external to our body as well as what's in relation with it. But isn't the idea of a 6th sense among our species conceivable, or rather a 10th sense? That is what has appeared to be more and more plausible for the last decades. Not a superpower, or anything related to the supernatural, but a tangible reality based on credible scientific observations. This 10th sense, which isn't much studied yet even though it is of growing interest for the scientific community, is more commonly known as magnetoreception, which implies the ability to perceive the magnetic field. The lines of a terrestrial magnetic field are indiscernible forces which originate from the constant motion of molten metals in the Earth's core, that only compasses and magnets can translate. They cross the planet at any point, from the North Magnetic Pole to the South Magnetic Pole, and their intensity on the Earth's surface varies. Despite a strong skepticism among the scientific community until recently, an increasing number of experiments support the hypothesis. Not later than 1963, researchers Vilchko and Merkel observed that by trapping robins, a type of migratory bird, in a cage in which the magnetic field is disrupted, the latter attempt to move in an unusual direction. We'll still have to wait a few years before the premise of the magnetic sense among most migratory species can be considered a scientific consensus. However, the human being isn't a migratory animal, but this fact doesn't disprove the theory that we are indeed endowed with this ability, just like other non-migratory species and some plants. Another remarkable proof of this behavior was discovered when in 2009, Bird's team from the University of Duisburg-Essen in Germany took the initiative to study satellite footage of herds of cows and herds of deer. They noticed that these mammals tend to naturally place themselves parallel to the north-south axis, except when close to high-voltage power lines, which disrupt the magnetic field. By combining these informations to Blakemore's hazardous discovery in 1975, which reveals for the first time the presence of magnetite in marine sediments, scientists began looking for this molecule in other beings, and they ended up finding some in the human brain. Indeed, this material is able to orient itself using geomagnetism, and is always aligned to the north-south axis. It is mainly used in compasses needles. The third hypothesis is then established. Each head movement would induce that of the magnetite in the brain. But there hasn't been any conclusive observation yet on this matter regarding the human being. The second hypothesis, which differs from the former one, seems nonetheless as plausible. It involves the cryptochromes, light sensors found in the retina, which, once in contact with light, produce 3 electron pairs whose position depend on the magnetic field, and would thus determine the information communicated to the brain by the optic nerve. This conjecture is based on several studies. At the Leibniz Institute in Germany, scientists managed to locally and temporarily anesthetize the cornea of the few bats with an ophthalmic solution. By following their late summer migration, the individuals all flew towards random directions. This outcome is proof that the cornea is able to send specific environmental signals. Other experiments also tend to confirm this hypothesis. In 1993, it came to light that robins are only able to read the magnetic field when in contact with blue and green lights, colors that cryptochromes perceive more easily. Furthermore, in 2011, scientists from the University of California in Irvine, in the United States, have successfully created flies deprived of cryptochromes, which thereby became unable to orient themselves with the terrestrial field. They finally recovered this sense when they were given the human cryptochrome gene. Until recently, The diverse experiments aiming to identify a magnetic sense among human beings were based on behavioral decisions of the participants and weren't successful. Since we wanted to verify this theory, it became necessary to set up a device that could provide scientific results. As a result, the study led by geoscientist Kervink and neuroscientist Shimojo from Caltech in collaboration with neuroengineer Matani from the University of Tokyo comes into play. They want to demonstrate that human brain waves respond to the magnetic field. To do so, they built a Faraday cage, an electric and electromagnetic wave shielded chamber in which 34 candidates sat in silence and in complete darkness for an hour. During this time, the team changed the magnetic field inside the cage using electrical coils. The electrodes disposed on the head of each participant allowed the scientists to notice changes among most of them. By focusing on the alpha waves, the cerebral rhythm resulting from the brain's electrical activity, which are usually at their highest when the brain is resting and undergo a significant drop when sensorially stimulated, scientists observed that the same pattern occurred when the magnetic field was modified. It's also important to point out that the participants' brain reacted to the stimuli seemed to only take into account modifications of the magnetic field when its orientation is similar to the place they're from. The human being possesses, after all the tools to interpret the magnetic field. But is even the signal of any importance to the brain? Why keep a sense that we cannot use? It is conceivable that our not-so-distant ancestors, who had a nomadic lifestyle as hunter-gatherers, used it to orient themselves, but that we lost the need of it. It's still to this day a field that offers many opportunities for discovery, but the influence of the magnetic field being rather weak on the globe's surface, it makes it harder to study, without even taking into account the psychological blocks and stereotypes that such a topic creates among most people.